Good morning. Hope everyone's staying warm. Today, we're going to be doing some review. I'm going to go over the practice exams, but I'm going to start off with the synthesis problems that we left off at the end of Friday. So, taking a look at this first one here, I gave you guys the hint that this is going to need protecting group. So with these kind of problems, if I want to do a protecting group, something that I need to look out for is I need to find a way to differentiate between my two oxygens. So one problem you could run into with this is if you threw in LAH. I'm going to draw this in red because this is going to be, oh yeah. Do I have it set up? Okay. Just making sure it doesn't play a sound when people enter the room. Okay, so if you throw in LAH, you're going to run into this issue where you can't protect one of these over the other one. And same thing if you just try to do the Grignard first. You're going to need to selectively reduce, protect, and then in this case, it looks like you're going to have to reduce again. But if you just try to like hit it with LAH, which is kind of like a hammer, it's going to reduce absolutely everything. If you throw in, TMS chloride at this point, they're both going to get protected. You throw in TBAF, they're both going to get deprotected. You kind of run into a little problem there. So instead, if we use sodium borohydride, which is selective for just ketones and aldehydes, we can get this alcohol by itself. Throw in TMS chloride. And from here, this should be Cl, not Cc. Well, lowercase l. We are good to go. So taking a look at our final product here, we have two different groups, which means we can't just throw in a Grignard here, because if we throw in propyl Grignard, it's going to add two propyl groups. So we're going to have to do a little trick where you reduce and oxidize again. So if I fully reduce this with LAH, and the screen's still, yeah. I can make my alcohol, and then I can oxidize this to just the aldehyde with PCC. Do 1/2 of my Grignard here. So let's do the propyl first. And then we can kind of do the exact same thing over again. So PCC lets us oxidize it again. We can throw in the Grignard. MGBR here. This is going to be a lot of steps. All right. From this point, we've created the left half. We need to essentially do a Grignard on the right half. So if we deprotect, TBAF, and I promise they're not this long in your actual exam. You can oxidize. You're going to have to protect again. Yikes. TMS chloride. Because this OH is going to react with the Grignard. Oh, this should be TMS. And then I'm going to throw these all together. Adding an ethyl Grignard. TBAF to deprotect again. We'll get you to your final product. So this was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 steps. The one in your exam, I think, is you have a choice between two, like you do on those practice exams. One of them is 6 steps and one of them is 7. So clearly a lot less than this here. But because we did this one over the weekend, I gave you guys some extra time to kind of figure it out. This one is particularly long. Okay, I'm going to go over the other one. Which is a good amount shorter. Okay, so this one here, if I look at my starting material and my product, I've got this, which probably fits into here somewhere. I need to make a bunch of carbon-carbon bonds. I'm probably doing Grignard reactions. It'd be impossible to make a triple bond here in order to add carbon-carbon bonds. So at some point in my synthesis, I'm going to need this in order to add these two groups. And then from there, I'm probably going to get this with an alcohol on it. Oops. So kind of just working in backward pieces. And then from these points, I can kind of try to connect the synthesis. So going from here to here, I got nothing on here. I can either throw in Cl2 in light or Br2 in light. It doesn't really matter. I'm still going to have to go through the same pathways. So if I throw in Br2 in light, I could brominate. And then eliminate with some base. Get a double bond. I want an alcohol over here, so throwing in BH3THF. And peroxide NaOH. Gets me to my terminal alcohol. Throwing in PCC can get me to my aldehyde. From here, I'm just doing Grignards, so I need an ethyl group. Ooh, is that one too many? Yeah, that's one too many. I need to add a cyclohexane or cyclopentane with a carbon on here. I'm gonna need to oxidize again. So PCC. Another Grignard. And then just PBr3 lets me do a transformation from an OH to a bromine. Let's see, this is 1, 2, 3, 4, 5, 6, 7 steps. So this is a lot more similar to what you guys might see on one of your exams. Okay, so I'm going to go through, I'm going to start by just going through these practice exams and telling you which ones you don't have to do. Some questions in the chat. On the exam, you can just say base. In this case, there's only one type of proton. They're all these symmetrical protons, so you don't have to say large or small. And you don't have to specify what type of base for this. Okay, so let's take a quick look at the fall. So this is, yeah, fall 2020. If you're going through these, we didn't learn this. We didn't learn this yet, so you can cross these ones out. On your NMRs, this is an ether, but I'm only going to test over alcohols and alkyl halides for the first exam, so you could technically cross this one out also. All right. We can get rid of, I think it's just these two on this page. Radicals. Oh, technically this one also. Looks like it's so this whole bottom one we didn't really cover. Didn't cover this one. Didn't cover this one. Didn't cover this one. Ooh, one of these we did. One of these we didn't. So most of this page you guys can't do. You can only really do these two problems here. Let's see. I believe you can do both of the synthesis problems and both the mechanisms. So that puts us on exam 1.1. Can't do this top one, can't do the bottom one. You can do this one, you can do this one, you can do this one. Okay. And I'm gonna cross out this top NMR, which is an ether. This reaction page, we can cross out this whole section. See, I think same thing over here. This whole section can go. Looks like you can do that. And then this mechanism we can't do, or this synthesis problem. Oh, sorry, some questions in the chat. Probably people asking me to slow down. Yeah, I'll post which ones I crossed out. Someone said sorry, which one on the first page of the first exam. First page on the first exam, only just 1 and 4 can be done. Other questions? Yeah, I'll post it. How are the exams done? So the exams are done in person unless you signed up for the online exam, which you can still email me about. So if you guys are coming to the Lead Center, you need to bring some sort of either like a clipboard or a textbook to write on top of. Okay, so I think I've got 1.2 to still go through, and then I'll start going through some of these problems. So that one, you can do all the nomenclature. This NMR from 1.2, I'm going to cross out. Let's see. Reaction page. This one. I think you should be able to do the rest of these. Cross some stuff out. And this whole bottom one. Yeah, anyone can sign up for the online exam. Just send me an email. All right. Can't do this one here and then the rest of this. you should be able to do. So I'm going to go through a few of these. I might start with this top synthesis because this is one that tripped up a lot of people in a previous term. Oh, some more questions in the chat. The exam is 50 minutes. If you're doing the exam online, you don't need to be on campus. Okay, so this top one tripped up a lot of people because I think that's something I see a lot on these exams is that people don't necessarily do what the reaction is supposed to do. They do what they want to get out of the reaction. So for this first one here, if you throw in a Grignard with this, so we've need to add 2 carbons because most likely this is going to fit into this here. Oops, sorry, it's a little off the page. So when you throw in this Grignard, draw it out. What you're going to get from this reaction is this. So your Grignard does an attack here, kicks up these electrons. You end up getting your OH in this position. What we saw the most from this exam, I think this exam was about like a year ago, maybe a year and a half, was this. The other mistake that people make a lot, so this is where you'd have to be like attacking at this position in order to generate this. And that was a big issue that we saw. Just people not like, because this would be a lot easier to get to your product from, they kind of like tried to force it in this case. The other mistake I see a lot on these is people not reducing the aldehyde when they do a Grignard. So a lot of people will draw this reaction and go straight to, I guess based on here. Yeah, 600. And they'll draw this, where they kept the ketone intact as opposed to actually reducing it here. So when you actually do this reaction correctly, from here, we are going to want to make a double bond. And we're going to need to use a large base to do so. So we're going to need to throw in tolusyl chloride and pyridine. From here, you can eliminate. So putting in a large base. We want an alcohol in the end, so BH3THF. Oops. and then oxidizing with PCC can get you to your product. Some more questions in the chat. Yeah, I can try resetting the connection to see if it's a little sharper. Let's see. Maybe I'll actually. Sources. See if that cleared it up at all. Didn't seem to have the dramatic transformation like it did last time, but okay. Let's see. So this was from 1.2. Let me take a look at the ones from 1.1. Okay. So this one is a protecting group one. And it's another example of making sure you do the right reaction. You don't just kind of try to force it into a hole. Let's see some questions in the chat. So it's a little better. Okay, good. So taking a look at this, we got to add some sort of group here. This is going to be a pretty similar problem in terms of things you need to do. But in this case, we have this free alcohol here, which is kind of going to muck everything up. So throwing in a protecting group first is going to be really helpful. TMS chloride. Oops. Lets us get to here. And again, this is where people kind of got thrown off. So if you do the reaction as you'd expect, so throwing in 1, 2, 3, 4 butyl Grignard, you're going to get this. And this is another one where people just kind of put a lot what they wanted to see. So a lot of people ended up like writing their alcohol on this position, which would make it a lot easier to get to the next part. Other people left this as oxidized. But again, that's not going to happen. So from here, we got to shift over our alcohol and then oxidize it. So probably same steps, TMS chloride or TS chloride. Or actually really probably easier to just throw in SlCl2 to do the same thing. That lets you have a chlorine. It's going to be a lot easier to work with. From here, a large base. Oops. OTMS. And then we're doing the same thing we just did. So BH3THF followed by PCC. H2O2 NaOH. Gives us the oxidized form of our product. We just need to take off that protecting group. And we can get to our final product. Someone asked, on the exam, do you want to write large base or give an example of base? You can just write large base or small base. We kind of touch back on these more in chapter 20. And at that point, I'll have you guys start writing in specific bases. Okay, I want to look at the, which synthesis problems did we have last semester? One of them is really similar to, oh yeah, that one was a mess. I should have changed that on the practice exam. We basically did that one in class. Okay, so I'm going to do some NMRs because these are really similar to things you guys have already seen before. More questions in the chat. What do we got? Online would be the same as the in-person. Yes, in your Canvas, now you need to know the mechanism for hydroburst and oxidation. Oh yeah, sorry. Don't worry about that. I don't think we actually went through that mechanism. So you can cross that one off the list. That was my mistake. So the BH3, yeah, don't worry about the BH3 THF mechanism. We did not cover that one. Sorry about that. All right, so let's take a look at this NMR here. We've got some interesting stuff. We have an out, most like an OH, this like small little broad peak down here. This is practice exam 1.1. So I'm going to draw that in as an OH. We've got a CH2. We've got two CH3s. We've got another CH3 here. And we got some peaks. So this is 4. Should have 3 neighbors. This is 1. Should have 0 neighbors. This is 3. Should have 2 neighbors. Taking a look at this. So there's nothing in this 3 to 4 range. And most likely that means that whatever is attached to my alcohol is going to be a carbon that doesn't have any bonds to it, or sorry, any hydrogens on it. We also have this singlet here, which means it has 0 neighbors. So we can start by drawing that. We're going to have an OH attached to something with nothing on it. These two CH3s are supposed to be attached to something with no hydrogens on it. So putting CH3 here. I have a CH2 and a CH3 left. CH3 would be terminal, so it has to be a CH2. It's supposed to have 3 neighbors. So putting this CH3 here would give me my product. from this point doing some labeling. So A, B, C, D here. A is going to be our alcohol. B is going to be our only CH2. C is going to be these two symmetrical CH3s. And then D is going to be this terminal CH3 here. Let's see. I want to do the one from let's do this one from, this should be from 1.2. So taking a look at the symmetrical one. We again have an OH peak. We also have an oxygen up here. We've got a CH2, or sorry, a CH here. We've got two CH2s that are symmetrical. And two CH3s that are symmetrical. Usually when you have a 4H and a 6H, it's going to be kind of a longer branch. But we can start here. Oh yeah, peaks. 1, 2, 3, 4, 5. Should have 4 neighbors. This is 1, 2, 3, 4, 5 again. Or that's 6. That's 5. Yep, 5. Should have 4 neighbors again. 3 should have 2 neighbors here. All right. So this one's in 3 to 4 range. It's attached to our OH most likely. So starting with that CH there. It should have 4 neighboring H's. So that would be CH2, CH2. Our CH2 should have 3 neighboring if it's the symmetrical 4H, which is the only option. So it needs to have 4 neighbors. It currently has 1, so it would need a CH3 on either side to get here. Labeling these. A, B, C, D here. A is our OH. B is going to be our only CH here. C is going to be our symmetrical CH2s. And then D, up here, is going to be our symmetrical CH3s. All right, let's do, I'm going to do a naming one. I'm going to do a cyclic naming one because I haven't really talked too much about these. So this should be 1.2. And I'm going to do the last of these nomenclature problems. So for cyclic compounds, we've got, numbering is always, I mean, it's not always a little bit trickier. If you have a substituent like an alcohol on there, it really helps because that's going to be your anchor point. So for something like this here, my carbon one is always going to start on that like highest priority group when it comes to naming. So that would be this alcohol. And then we're just kind of going either, man, I need like a skinny marker for this. Regular pen. 1. In this case, it's going to be better to go clockwise in order to get a lower number. So 2, 3, 4, 5. That way This ethyl is 2, this methyl is 3. If we went the other way, it'd be 1, 2, 3, 4 methyl, 5 ethyl. So that'll give you a bigger number, so you want to avoid that. If you end up with, we'll draw an example where you have both of them. We had, let's just do the same thing. Something like this. It's actually going to go down to alphabetical. So this is still 1, 2, 3, 4 versus 1, 2, 3, 4. Because this is an ethyl versus a methyl, this is an E, this is an M here. We're going to favor the E. So this would be 2, 3, 4, 5 in this case. But getting back to this one here, we have a cyclopentanol because it's 5 carbons. You don't have to put where the OL is because it's always on 1 for these, which is nice. We have an ethyl group on 2. We have a methyl on 3. Let's see. We are needing to do RNS. No, I'm gonna stop using this because this is probably harder to see. So starting with this alcohol here, that's gonna be our highest priority because it's an oxygen. It is in the dash position, which means whatever we get at the end, it's gonna need to be flipped. So this is our highest, followed by the right side here because it's got this extra group. This should be R, but because this is forward, this is going to be S. Or sorry, because this is back, it's going to be S. Redrawing this. We have ethyl, so carbon bonded to carbon with an ethyl chain, carbon bonded to carbon with an oxygen here, carbon bonded to carbon as well as this carbon here. So our highest priority group is going to be this OH, followed by our right side here, and then lastly our ethyl chain. This is in the wedge position, so it stays as is. This is going counterclockwise, so this is also S. Taking a look back at this one, this is a dash, so we're gonna need to flip it at the end again. We've got carbon bonded carbon, or here and here, versus just this chain. So this is gonna be 1, 2, 3. Should be S, but we are going to flip it because this is a dash. So this will be 3R. Putting this all together. 1S, 2S, 3R. Ethyl comes before methyl. 2 ethyl. 3 methyl. Cyclopentanol. Yeah, I'll redraw the pentanol lower. Question in the chat. Yeah, you flip it even if the wedge is in the 3 position. It's really, you flip it anytime that your 4th position is, so your 4th position is this H, and it's on a wedge here. And anytime that your fourth is on a wedge, you're gonna need to flip it. All right. Is there anything else I think is tricky? Any other questions from you guys? There's about 5 minutes left. The exam will have the exact same format as last year's exam. You'll have the page of nomenclature, pick one of the two NMRs, page of reactions, page of fill in the reagent, pick one of the two synthesis, pick one of the two mechanisms. It'll probably be a little bit. This Zoom will be posted. I don't know. I usually get them up by around noon. Let's see. If the OH is on one, we don't have to put it in the name. Someone asked when is the exam? The exam is on Wednesday. Grades back should also be Wednesday. Is there a dash between methyl and cyclopentanol? There is not. This should be one word. I'll write it up here. This is starting from the 3, not in teal. 3-methyl cyclopentanol. If you put pent 1-all, it's also still correct. But if it's on 1, it's implied. So you don't necessarily need to have. You could have also put pent ane 1-all. Those are both considered correct. It's just like a shorthand version. If it's ever on 1, you technically don't need to write it. Let's see. Message. Sign up for the online exam. Just send me an email. I'll send you some details when you do that. I think I said exam score should be ready by, I don't know, I'm guessing 6 p.m. that night. We're grading around 3 p.m. All right. If you guys don't have any more questions, I will see you guys on Wednesday.